Welcome everyone. I am J. Aravind from Mailtech Multitech Engineering College, Chennai. I would like to explain my PG project, Detection and Prevention of Node Replication Attack through Stealthy Mode Trapping in Wireless Sensor Networks. First of all, I would like to thank my internal guide Mr. M. Rajesh Khanna, Assistant Professor, Department of IT. And I would also like to thank the other faculty members, my HOD, my project coordinator and my principal. Abstract. The main objective of this project is to expel the sensor nodes which are compromised by one of the security attacks known as node replication attack in wireless sensor network. In this attack, an adversary captures an unattended node by compromising the node ID and secret credentials of that node and thereby falsifying the information which are sent to the task manager. The base station will act as an access point to the network of sensor nodes, and the task manager will act as an end system which controls all the other sensor nodes in the network. The communication between the sensor nodes are periodically recorded in a database at the task manager. By using that information, a new technique is implemented known as stealthy mode trapping, which is used to trap the attacker and eliminate the nodes which are attacked from the sensor nodes. The analysis and simulation results show that the proposed technique will provide better and efficient security than the other existing schemes. Problem statement. Sensor nodes are usually not made up of tamper-resistant hardware. Since there are lot of sensor networks that are used, they will have to reduce the cost. These sensor nodes are deployed in an environment where an attacker from outside can easily enter and join into the network. These attackers remain passive for a few moments, and after collecting the details in the sensor network, such as node ID and secret key, they will replicate the unattended node using their node ID. Ultimately, they will either alter the message that is sent to the sink or base station, or they will eavesdrop the information that is communicated between the sensor nodes. Existing system. The existing system uses a protocol known as XCD. In that, when two sensor nodes U and V meet for the first time, the two nodes will exchange a random number between them. On their second meet, the two nodes will ask to exchange the same random number. If any one of the nodes fails to exchange the same random number, that node is considered as an attacker node. Limitations. The major drawback of XCD is that it assumes the sensor nodes are not collusive. This system also utilizes more amount of resources. Existing system architecture. Here, the two sensor nodes exchanges random number between them, and the other sensor nodes will also exchange the random number that has been taken part in the communication process. Finally, those information are sent to the base station. The black node represents the attacker node, and the orange node represents the unattended node, and the violet node represents the active node. Proposed system. In the proposed system, instead of giving random numbers to each sensor nodes, a new technique known as stealthy mode trapping is implemented as a software at the task manager. Based on the information recorded in the database at the task manager, it checks whether there are simultaneous updates recorded at the same time for the nodes with the same ID at different locations. If two IDs match, then the task manager will send requests to the two nodes with the same ID to send its previous locations using stealthy mode trapping. Based on the information provided by the two nodes, the base station will differentiate those two nodes and exclude the replicated node from the network. Proposed system architecture. Here, the violet node represents the honest node and the black node represents the attacker node. All the nodes communicate between each other and send the messages to the base station, and the base station will pass the message to the task manager through the internet. Based upon the information recorded at the task manager will be able to differentiate the attacker node and the honest node. The task manager asks for the previous location of the two nodes that has been detected as malicious nodes. The node which can able to give the correct location is considered as an honest node, and the other node is excluded from the network. Advantages of the proposed system. The proposed system eliminates the unnecessary communication between the sensor nodes. It saves the resource for each and every sensor node, thereby extends its overall lifetime. It provides a better security than the existing system since it monitors the nodes in a distributed fashion. Module split up. These are my 4 modules. Creating server and client connection, replicated nodes with the same ID are created, stealthy mode trapping implementation, exterminating the attacker nodes. Data flow diagram. First of all, the sensor nodes updates the information periodically to the task manager. In level 1, the sensor nodes will send the node ID and location to the base station, and the base station to the task manager, and the task manager will ultimately take the efforts. Level 2, the sensor nodes updates the node ID and location to the base station. The base station will update the information to the task manager. The task manager records those informations in the database. Finally, the stealthy mode trapping is done in order to remove the replicated node from the network. These are my screenshots. Sensor node 1. In sensor node 1, there are incoming message, outgoing message, and the destination node, the send button, and the location. Sensor node 2. The sensor node 2 is also having the similar information as a sensor node 1, and its location is N23. Sensor node 3. The sensor node 3 consists of incoming message, outgoing message, and sensor node 4 as the destination, and its location as N34. The sensor node 4 is having the destination as sensor node 3 and its location as N13. The base station consists of all the messages, location, time of source node of the sensor network communication. It will choose to which task manager the information has to be sent. The task manager contains all the information about the individual sensor nodes, and the details that are recorded in the task manager are stored in the database. The task manager will ultimately take the efforts to remove the replicated nodes from the network. Thank you.